There are 5 questions on in-class exercise 2.1. You can start working on question 1 and 2. After you finish question 1 and 2, you can resume the lecture. If you have finished question 1 and 2, we can resume the lecture. In class 2.1 asks you to compute the regression equation based on this data set. First, we compute the slope b. It equals to covariance of x, y divided by variance of x. To get the covariance, we compute mean of x, which is 5. Mean of y is 7. Then we subtract mean of x from each x. We will have -1, 2, -2, 0, and 1. We subtract mean of y from each y. We will have -6, 9, -3, 0, and 0. Then we multiply these two columns together. We will have 6, 18, 6, 0, 0. We add these 5 numbers together. Sum of cross product is 30. We divide 30 by 4. Covariance between x1 is 7.5. The last column, we square x minus x bar. We will have 1, 4, 4, 0, 1. We add them together. This gives us sum of squares for x. It is 10. We divide 10 by 4. We got 2.5, which is variance of x. Slope equals to covariance divided by variance of x. It is 3.0. Then the intercept equals to y bar minus b times x bar equals to 7 minus 3 times 5, which is -8. What is the regression equation? The regression equation is y hat equals to 3x minus 8. Y hat equals to 3x minus 8. The slope is 3 and the intercept is -8. That is, when x is 0, y equals to -8. That is the intercept. And this line crosses the dots of x bar and y bar. X bar is 5, y bar is 7. This point always sits in the line. When x is 2, y hat equals to 3x minus 8 equals to 3 times 2 minus 8. It is -2. Next, we will talk about let's see a correlation coefficient and the regression coefficient. Correlation coefficient describes the scatter plot, and the regression coefficient describes that line. Apparently, they all describe the data set in different ways. There is a interconnection between correlation coefficient and the regression coefficient. We can approach this question from mathematical formulas. So the equation for the slope is covariance divided by variance of x. And the equation for correlation coefficient is covariance of xy divided by SD of x times SD of y. What is the relations between regression coefficient and correlation coefficient? This is a formula. And if we rewrite the formula, so the denominator, we put it as sx times sx. Then we add another part on the right, so we do sy over sy. So that's about the same thing. Then for the bottom, sx times sx times sy, we switch the position of sx and sy. It will become covariance of xy divided by sx times sy times parenthesis sy over sx. Then when you look at the first part, this is the formula of correlation coefficient. So this part could be simplified by correlation coefficient times SD of y divided by SD of x. That is the relations between regression coefficient and correlation coefficient. That is B equals to R times SD of y divided by SD of x. Now you can continue in class exercise 2.1, working on question 3 and 4. After you finish question 3 and 4, you can resume the next lecture. So question 3 asks you to compute the correlation coefficient. Then the bottom of the correlation coefficient is SD of x times SD of y. We need to find out SD of x and SD of y. So we can continue the table. We have the variance of x, which is 2.5. Then standard deviation is square root of 2.5. It is 1.58. Then to get SD of y, we square y minus y bar. So we have 36, 81, 9, 0, 0. We add these 5 squares together, we have sum of squares for y. It is 126. We divide 126 by 4. We will have 31.5. That is variance of y. SD of y is square root of 31.5. It is 5.61. Now we have the SD of x and SD of y. We can compute the correlation coefficient. It is 7.5 divided by 1.58 times 5.61. So it is 0.85. Question 4 asks you to confirm the equation. Question 4 asks you to confirm the equation B equals to R times Sy divided by Sx. R is 0.85, Sy is 5.61, and Sx is 1.58. So if you compute this equation, you will have 3.01. That is the slope. Next, we will learn how to use SPSS to run regression. Okay, so this one, using SPSS to run regression, you enter the data, you have x and y, and you have 5 numbers under x, 4, 7, 3, 5, 6, and 5 numbers under y, 1, 16, 4, 7, 7. To run regression, you click on Analyze, click on regression, point at linear, then you will have this window. You move X into block 1 of 1 and move Y to dependent. Then click on OK. This will give you the regression analysis. That's the output. Okay, it gives you two tables. The first is model summary, and the second is coefficient. So here we have one predictor X. We use X to predict Y. When you look at the coefficient table, the constant is -8. This is the slope. And the number next to X, 3.00, this is, -8 is intercept, and 3 is the slope. Then the t-test, testing the significance of the slope, is 2.739. Then the p-value is 0.071. It will also give you the model summary. Under model summary, under R, the correlation between X and Y is 0.845. Now you can report the regression results in APA style. That is, X did not significantly predict Y. B is 3.00, T parenthesis 4. 4 is degree of freedom, is 5 minus 1. It equals to 2.74. P-value is 0.07. Now let's see how to create the scatter plot and add the best fitting line. We did the scatter plot last class. With the dataset, you click on Graphs, then click on Scatter/Dot, then click on Simple Scatter, Define. Move X to X-axis, move Y to Y-axis, click on OK. Then you will have the scatter plot. When you have the scatter plot, click on the scatter plot, then click on Edit, then Edit again. This will bring the chart editor. If you use PC, you can also double-click the scatter plot. It will open the chart editor. When you have the chart editor, click on Element, then click on the Fit Line at Total, then close. You will have the best fitting line added to the scatter plot. It looks like this. So you have 5 points scatter plot, X on X-axis, Y on Y-axis, and it will add this best fitting line on the scatter plot. So Y equals to -8 plus 3X. Now you can work on the remaining questions and finish the in-class 2.1. Finish those SPSS questions. After you finish the in-class exercise 2.1, we talk about correlation and regression. For correlation, it does not matter which variable goes on the x-axis or y-axis because correlation describes the relationship between the two variables. It does not matter which variable on x and which variable on y. So if we want to study the correlation between parents' IQ and the children's IQ, either parents' IQ or children's IQ could be presented on x-axis. The correlation is positive 0.50. In contrast, when you run regression, remember the purpose or the function of a regression line is to make predictions. We use parents' IQ to predict children's IQ. Therefore, parents' IQ is called independent variable or IV. It must be presented on x-axis. That's your predictor. And the children's IQ is the dependent variable with dV. It must be presented on the y-axis. Now we have the scatter plot, parents' IQ and children's IQ, and we add a best fitting line. Our goal is to use parents' IQ to predict children's IQ. Therefore, X must be on x-axis and the outcome must be presented on y-axis. For example, if parents' IQ is here, then we use parents' IQ to predict children's IQ. That is the purpose of using the regression line. Y hat. Okay, so if you're comfortable with these materials, you can work on Lab 2 worksheet. Then after you finish Lab 2 worksheet, you can turn it in by midnight next Wednesday, okay, February the 4th. Today, we reviewed the correlation. We learned what is the best fitting line and the rationale of choosing the best fitting line. We learned how to compute the regression equation by hand, how to compute the slope and the intercept. Then we learned the function of a regression line. Given an x, how to use the regression equation to predict y, or the y hat. We did an in-class exercise going over all the hand calculation and the SPSS and the scatter plot and the adding the best fitting line to the scatter plot. Finally, we explained the connections or relations between regression and the correlation. There is a relationship between R and B, and we constructed the scatter plot adding the regression line to the scatter plot. So that's the end of today's lecture. Remember to turn in the lab worksheets via Canvas by the due time. Thank you. I'll see you next week.